We are going to simplify some exponential expressions, aiming to leave only positive exponents. I wrote over here some definitions related to what a to the power of something means, and also some properties that we are going to be using. So I encourage you to stop the video now and check that you are familiar with those definitions and properties that we are going to use. I wrote here the three expressions that we want to simplify, and I think at this point we should stop the recording for a bit, so I give you time to try to simplify the first one before we do it together. We may be at this point really tempted to get together these two expressions. With x we have in the numerator, we have x to the power of 1 over 3 and x to the power of 1 over 4. The problem is that those two expressions are being summed, and we do not have any property that tells us what to do with the sum of exponential expressions. So we don't have any way of, any direct way of simplifying this. So instead of doing that, what I'm going to do over here is to write this as a sum of two algebraic fractions. We have one that is x to the power of 1 over 3 divided by x to the power of 1 over 2 plus, and then we have x to the power of 1 over 4 divided by x to the power of 1 over 2. So maybe it would be more natural for you to go from the right to the left, not from the left to the right that I just did. But if we look from the right to the left, we have two algebraic fractions that have the same denominator. So since the denominator is already common, to sum them, we keep the same denominator and we need to sum the expressions in the numerator. And of course, if a is equal to b, b is equal to a, so just by properties of sum of fractions, the step I just did is true. So let me just write here what I did is sum of fractions. Okay, so what do we do with that? Now we do have property number 2 that tell us what to do when we have quotient of exponentials with the same base. So here we have x to the power of 1 over 3 minus 1 over 2 plus x to the power of 1 over 4 minus 1 over 2. Okay, here we just need to deal with fractions, so we need to see what is 1 over 3 minus 1 over 2. I'm going to take common denominator 6, so I need to multiply the first fraction by 2 and the second one by 3, so I get minus 1 over 6. So this is, for the first one, x to the power of minus 1 over 6. Let me just make this a bit smaller because we don't really need it. Okay, that was the first fraction over here. Then we have a quarter minus a half. That's minus a quarter. So that's plus x to the power of minus 1 over 4. We are not done yet because our question says that we have to leave only positive exponents. So I'm going to write the first expression as 1 over x to the power of 1 over 6. And then plus the second one, 1 over x to the power of 1 over 4. And that way we simplified our first expression. To simplify the second one, I'm going to begin with an example. That's a good thing to do. I mean, of course, solving one example will not solve the whole question, but sometimes if we are able to solve an example, we're able to see what's going on and we are able to generalize it. So let's say, I don't know, here that n is equal to 5. So here we will have 3 to the power of 6 minus 3 to the power of 3. So this is just an example. Well, if this is what we have, we may notice that actually 3 to the power of 3 is common to both expressions. So actually, we could rewrite this as 3 to the power of 3 times 3 to the power of 3 minus 3 to the power of 3. So we can take 3 to the power of 3 as common factor, and then we'll be left with 3 to the power of 3 in the first term minus 1. So we will have a simplified expression, hopefully over here. Well, I mean, this is a number. We could find what this number is. That will be 3 to the power of 3 is 27 times 27 minus 1, 26. I don't care about doing that multiplication. But hopefully this gave us the idea that what we should try to find is what is common between 3 to the power of n plus 1 and 3 to the power of n minus 2. And what I claim is what is common is actually 3 to the power of n minus 2, because we can write the first expression, the first term, as 3 to the power of n minus 2 times 3 to the power of 3. So let's check. Here, let me write minus 3 to the power of n minus 2. But let me focus for 1 second in the first part, 3 to the power of n minus 2 times 3 to the power of 3. We have 3 to the power of n plus 1, and I claim that these two things are equal. And what I'm using over here to say this is actually the first one of our properties. It's just that I'm going in the other direction. So we have one expression that has n plus 1, and what I'm saying is, well, instead of n plus 1, I could write n minus 2 plus 3, because actually minus 2 plus 3 is 1. So it's an unusual for you way of using a very well-known property. So I hope I convince you that this works, because n minus 2 plus 3 is equal to n plus 1. And then if we go back to our expression, we see now that 3 to the power of n minus 2 is common for both expressions. So we have common factor, and then we have left inside the brackets 3 to the power of 3 minus 1. Again, we can expand to check that this is actually the expression we had. This is 3 to the power of n minus 2 times 3 to the power of 3 is 27 minus 1, 26. We could stop there, or we could go one step further and use our property 2 on the opposite direction. And we could say that 3 to the power of n minus 2 is the same as 3 to the power of n divided by 3 to the power of 2. Yeah, because n minus 2 is n minus 2. So we'll have that multiplied by 26. So this will be 3 to the power of n multiplied by 26 divided by 9. And I will accept this expression over here as simplified, but maybe in some sense this is even nicer. It's hard to agree with what it means, like really totally simplified. Hopefully you are pausing here and trying to solve the third one of our expressions. So what I'm going to do over here is try to see if I can get something out of that square root. What do I mean by getting something out of the square root? Okay, so I change color unintentionally here. Let me go back. Yeah, we have 1 divided by n, and then inside the square root we have n squared plus n to the power 4, but that has common factor n squared. So inside the square root I'm going to write n squared brackets multiplied by 1 plus n squared. And you can expand again to check that this is true. Well, why did I do this? Well, I did this because now we have n squared times 1 plus n squared, all of it to the power of a half. And we can use the property 4 that says that if you have exponent of a product, you can first take the exponents and then multiply the numbers. So in this case, I'll be doing 1 over n times, and then I'm going to have n squared to the power of a half times 1 plus n squared to the power of a half. And this is nice because we can simplify over here this using the property 3. We have a power of a power. So we have over here n to the power of 2 times a half. So that's just n. So this is 1 over n times n times 1 plus n squared, all of that to the powers half. And now we can simplify the n that is dividing and multiplying, and our final expression is 1 plus n squared to the power of half, or if you wish, square root of all of it.